Today, looking at solubility and dissociation, we've kind of danced around this topic a little bit with precipitates and why did some of those things form precipitates, why did they not? Well, it's because of this stuff. Solubility, a couple definitions here. So solubility, property of a substance to form a solution. So solution, something that looks identical from top to bottom, that is a mixture. Here we're talking about solubility in water is what we're going to focus on. And then dissociation, the breakdown of a compound into its ions. So when we add something to water, it breaks up into ions. This is true for only ionic compounds and acids. Covalent or molecular compounds, same thing there. But those do not break up into ions. So like sugar or, well, any other molecular compound doesn't break apart. It stays together, but it still may be soluble. So that's why we talk about these two kind of together for ionics and acids. So how do we know if something is soluble, or how do we know if something will dissociate or into its ions? Solubility rules, and you have a handout for this. So using that handout, using those solubility rules, here's some examples and things you just, how you would do this. So I find my compound in HCl and I look for rules that apply to that. So this one is soluble because of rules number 1, talking about group 1 metals, and then also rule 4, talking about those few halogens. The next one, ammonium bromide, so don't forget that weird polyatomic ion. This one's soluble because of, well, again, rule 2 talks about ammonium compounds being soluble. I've got to check my sheet here. Yes, that is rule 2. And then bromine, the same thing, rule 4 again. So you may see a couple of them. It doesn't take 2. You really only need 1 rule to prove that it's soluble or not. I lost my thought what I was going to say about that. KNO3, again, checking my rules. This one's soluble for, again, a couple of reasons. Rule 1, potassium, a group 1 metal. NO3 is also, so nitrates plus a bunch of other polyatomic ions are soluble as well. That's rule 3. Next one, AgCl. This one is actually insoluble. Yes, it does have one of those halogens, chlorine, except there are, except we have exceptions. This is a rule 4 exception. So rule 4 proved that one, rule 4 proved that one. This one, it's the exception. In rule 4, plus lead and one other thing, maybe mercury. So look at those exceptions, be aware of those exceptions. Don't just automatically, oh, I see chlorine, and then get that one wrong. Next one, Na2SO4. This one is soluble for a couple of reasons. Number 1, because rule 1 says that group 1s and group 2s are, group 1s are. And then in rule 5, this is one of the exceptions that say this one actually is soluble. Next one, sodium hydroxide. This is a rule, this is soluble due to rule number 6, and it's a rule 6 exception. Aluminum sulfide, Al2S3, this is insoluble, and that is rule 7. CaS, so calcium, hey, that's a group 2, but it says all sulfides are insoluble except group 1 and group 2. Calcium group 2 on your periodic table, meaning it's in the second column, or group 2A, I think is what I say on yours. So we're looking at the 8 rows that stick up higher than anyone else. So this one is, what did I say? Yeah, this one's soluble. And this is a Rule 7 exception. And then the last one, calcium carbonate is soluble, and this is a Rule 8 exception. Familiarize yourself with these solubility rules. I'm still going to give them to you on a test because I don't expect you to memorize them, but definitely familiarize yourself. How do they work? Things like that. And then be careful of those exceptions. Next up, looking at something we call dissociation. I put it in quotes because it's not really a reaction. You're not mixing two chemicals. And we're going to care about this for about a day, and we're gonna go beyond this. But this is just kind of thinking, okay, if I did put this in water, what happens? So what does that dissociation look like? Like I said, we're going to go beyond this, but knowing what happens is going to help you for what's to come when we talk about ionic and net ionic equations. So we have NaCl. What happens when you put NaCl in water? Well, it is soluble, so I got to check my solubility rules first. It is. So, okay, what does it break up? What does it dissociate into? This one dissociates into, well, think of its ions, Na and Cl, and they're both aqueous. But it dissociates into ions, so we need charges here. Well, I check my periodic table. Na is always a 1+, chlorine is always a 1-. Be careful to write your charges correctly. MgO, I check, yep, it is soluble, according to, can't remember what rule it is and I didn't write it down, but you can check your solubility rules, it is. Also, sometimes you'll see with the water over the arrow, sometimes you won't. We'll show that just so we know that, hey, we're looking for a dissociation. This breaks up, so since we said it is soluble, breaks up into these things. And then we need charges. Well, magnesium column 2 is always a 2+. Oxygen column 6 or 16, whatever you want to think about, this is a 2-. So make sure you have charges. Last one, PbCl2. If we mix this in water, check my solubility rules, and it's not soluble. So it's insoluble, or what you could say is, instead of writing insoluble, which is probably what I would do, but you might see it in a case where it says PbCl2 and they just put an S after it because it's a solid. It stays solid when mixed in water. Like I said, we're only going to use these for about a day, and then we're going to go beyond this and what happens when multiple of these things react, and really double replacement reactions. Not all of those produce a precipitate. We're going to show you how you find which ones do. So that's coming up next.